This video is about the hydrosphere and ionic compounds that are contained within it. The Earth's hydrosphere consists of all the water in the oceans, seas, lakes, rivers and so on. It also contains any compounds that are dissolved in that water. Most of the dissolved compounds in water are ionic compounds called salts. That's why the seawater is said to be salty. Examples of salts that are dissolved in the water include sodium chloride, which is table salt, magnesium chloride, and potassium bromide. These are all ionic compounds, salts that are dissolved in the hydrosphere. These salts are solid ionic compounds and they tend to form crystals. This is because they're made of charged particles called ions, i.e. positive ions and negative ions. Ions with opposite charges are really strongly attracted to each other. This means they tend to form a lattice structure where all of the positive ions and all of the negative ions are attracted to all of the ions that they're surrounded by, as shown in this diagram. This is called a giant lattice structure. Okay, a giant lattice structure. Ionic compounds tend to form giant lattice structures and they're made of crystals. This is because the chemical bonds in between the ions are really strong and they are called ionic bonds. A single crystal of salt is one giant ionic lattice, and this is why salt crystals tend to appear cuboidal in shape. Ionic compounds have high melting and boiling points. This is because the forces of attraction between the ions are really strong. It takes a lot of energy to overcome these strong forces of attraction and melt the compound, and even more energy to boil it. This is why ionic compounds have high melting and boiling points, which tends to make them solids at room temperature. If you think about it, table salt wouldn't be much good if it was liquid or gas at room temperature. Ionic compounds do not conduct electricity when they're solid. This is because the ions aren't free to move. They're held together by those really strong bonds between the positive and negatively charged ions. So an electrical current can't be passed through it. However, when an ionic compound melts or dissolves, the ions all separate and they're then free to move around in the solution, either in water or just in the melted solution of itself. That means the ions can carry the electrical current through the solution. This is why when they're dissolved in water, i.e. aqueous, or molten as liquid, ionic compounds do conduct electricity very well.